Welcome back, everyone. We're diving into a world of giant robots today.
Oh, it's gonna be fun.
It is. But we're not just looking at the finished product all shiny and cool. We're going
Yeah.
deeper. We're going to look at all the challenges.
Right, the nitty-gritty, all the stuff that makes it real.
Exactly. All the things that could go wrong. All the setbacks.
And how they get through them, how they actually make it work.
Exactly. And for this one, we're looking at the Hacksmith Industries YouTube video about Megahex,
Megahex. I love that
the
name.
world's largest rideable six-legged robot.
So for anyone out there who doesn't know, Hacksmith Industries, they're this team of engineers and makers. They build these crazy things, bringing ideas from movies and comics and, well, science fiction to life.
Perfect for our deep dive, right?
Absolutely. They show all the wins and all the fails, too.
Which is what we're all about, right? The failures, that's where we really learn.
Mhm.
Now picture this. 6 full-sized excavators
Oh,
welded together.
now we're talking.
Each leg controlled by a different pilot,
Like a giant mechanical spider.
made of construction equipment. So where did this idea even come from? A giant walking hexapod.
It's actually pretty funny. They were watching a video. Seems to be how most of their projects get started.
Right.
This video was of an excavator, and it was using its bucket to stand up and move around.
I've seen that.
Yeah, it's pretty wild. And they thought, well, what if we made it bigger? What if we added more legs? A giant robot.
Ah, I see the engineering mind at work. See something cool and immediately think bigger.
Yep, that's them. But they did have some sort of plan. They partnered with Princess Auto, who were awesome enough to give them the excavators and some cash to get started.
Wow, that's huge.
And they thought they could do the whole build in just 3 months.
Oh, the optimism. I have a feeling it took a bit longer than that.
You think? But even with a whole team of smart engineers, 6 excavators don't just become a giant robot, right?
Right. So how did they even start designing this thing? Did they have, like, blueprints? Or was it more making it up as they went along?
Well, a little of both, actually. They started with a rectangular frame design. Pretty basic.
Yeah, makes sense.
But they quickly realized at that size, it would be way too big
Yeah.
and totally unstable.
Makes sense. So what did they do? They must have had to change the design, right?
They did. What seems like a small tweak, but made a huge difference. They went from a rectangle to a hexagon.
A hexagon. Okay,
Yeah.
that makes sense for stability, I guess. But how did that make things harder?
Well, with a hexagon, every single angle has to be perfect.
Okay.
Think about it. Each leg now needs its own set of movements.
Like a specific way of moving.
Yeah. They called it a motion profile. And this is where the real-world engineering problems started popping up.
It's easy to get lost in the what ifs, but then you hit reality. And reality can be a pain.
Tell me about it. Things never translate perfectly from the computer to the real world, especially with, well, excavator parts. They're mass-produced, not exactly made for robots. They had to get creative.
I bet. So what did they do? They must have had to, like, modify these excavator frames.
Oh, yeah. Lots of custom stuff. They built special jigs and brackets just to get the alignment right. Even the welding. They thought it would take, 2 days.
Few days.
It took over a week. Grueling work.
It's amazing they didn't just quit. I would have been so tempted to just give up.
Right. But they stuck with it.
Mm-hmm.
And they got to see those legs finally attached. Megahex started looking like a megahex.
I bet that was an awesome feeling for them. There's a photo in the video. Megahex, all 6 legs on. It's mind-blowing. You can't even imagine how big it is until you see a person standing next to it. Tiny.
Yeah, it's huge. You really get a sense of how crazy this project was.
And maybe a little scary, too.
Maybe a little. I mean, it's not a toy. It's built with heavy construction equipment.
Yeah.
With a platform on top for people to actually ride on.
Yeah.
A lot could go wrong.
Oh, yeah. And they talk about that in the video, right? Cracked welds, hydraulic failures. It's a lot of weight and pressure.
They actually got one of the legs to lift and move with the hydraulics. Pretty cool to see.
That's got to be the best feeling, seeing all that work come together.
But getting one leg to move is nothing compared to making the whole thing walk. And they wanted to ride this thing, remember? They had to make 6 legs work together.
So how did they even begin to do that?
Well, they needed a system to, synchronize all those legs, make them move together smoothly. And that meant a lot of hardware and software.
Okay, so they needed it like a brain for this giant robot.
Exactly. They had a Linux computer for the main calculations, then a Kunbus Revolution Pi. It's like a super reliable industrial computer.
So that's the brain, but how does the brain tell the legs to move? How does it control those giant excavators?
Well, that's where custom PCBs come in. Printed circuit boards. They're like the translators between the computer and the motors that control the hydraulics.
Okay, that makes sense. But did it actually work? Or was it all just theory?
Well, they used simulations, like a video game version of Megahex.
That's cool. So they could, like, practice before doing it for real.
Exactly. They could see how the legs would move, if there were problems with the code. They even used their SolidWorks 3D models.
Smart. But I bet there were still some surprises when they tried to move the real thing.
Oh, yeah. They called it integration hell, which is a pretty good description.
So basically, where all those perfect plans hit the real world, what happened?
We'll have to find out after a quick break.
Integration hell. Sounds intense. So they did their simulations, they wrote all this code, and then they finally got to see Megahex in action. What happened? Did it work?
Well, it looked good at first. Megahex started lifting off the ground, legs moving, platform rising, and then...
No. What happened? Did it fall apart?
Not quite, but almost. The video says it was like curling up like a dying spider.
Yikes. The legs, they just started moving all wrong.
Yeah. The whole thing was shuddering. It seemed like the control system just, like, lost it. It had to be terrifying for them.
I bet they hit that emergency stop button pretty quick. After something like that, I don't know how they kept going. I'd be ready to give up and build something a little less, well, dangerous.
They're dedicated, that's for sure. But they knew they had to figure out what went wrong.
So was it a mechanical problem? Did something break? Or maybe those welds they were worried about?
Nope. Remember all that fancy computer stuff, the circuit boards and all that?
Yeah.
Turns out it was a code error.
Seriously.
One line of code was telling a leg to move too far past its limit.
So like a bug in the system.
Yeah. And that almost brought the whole thing crashing down.
That's kind of scary.
Yeah.
One line of code, that's all it took. So they fixed the code, and then what?
They tried again. And this time, Megahex stood up. All 6 legs on the ground, nice and stable. You can see in the video they were so relieved.
That had to be an amazing moment for them, seeing all that work actually pay off. It's one thing to see the computer, but the real thing, that's got to be something else.
It was a win, for sure. But they still had a long way to go. They didn't just want Megahex to stand there, they wanted it to walk.
Right. And I'm guessing testing a walking robot, especially one that size, takes a lot of space.
Their workshop wasn't exactly built for giant robot parades. To really test it, they had to get it outside.
I bet that was a challenge in itself.
Yeah.
Moving a giant robot. So Megahex is finally outside, ready for its first walk. What happened?
Well, here's where they really started seeing the limits of their design. Excavator legs. They're great for digging, not so much for walking. They weren't smooth or precise enough.
So it wasn't exactly a graceful walk.
More like stumbling around. Those excavator legs would drag, it would trip, even damage itself with each step.
Ouch. So much for that 3-month build time. They're way over a year in, the budget's probably blown, and Megahex can barely walk. What do?
They didn't give up. They really showed their dedication. They could have just said, this is a fail, and moved on. But they kept going. They analyzed every test, looked for weaknesses, made changes, and tested again.
Like a true engineer. Never give up.
Exactly. They'd look at all the data, make tweaks to the control system. They even changed how far each leg moved with each step, trying to find the right speed.
It's amazing how much work goes into these things. You think it's all computers and high-tech stuff, but sometimes it's just trial and error.
Absolutely. And they made progress, but it was slow. They had hydraulic leaks, sensors breaking down, all sorts of problems.
And they were paying for all this themselves, right? Must have been a lot of pressure. But they kept going. Did it ever really work?
There's this moment in the video. It's amazing. They finally fine-tune everything, run a test, and Megahex walks several steps in a row.
Also, I bet that was an incredible moment.
They finally did it, made Megahex walk. But this is the real world. Things don't always go smoothly.
Oh, here comes the boom. I knew it. What happened? Did Megahex go on a rampage?
Not quite. They lost communication with the controller, a loose wire.
So Megahex was like a giant robot on autopilot.
It was just stumbling forward, and then it stepped on their trailer.
You can't make this stuff up. So they fixed the wire, got Megahex back online, and they probably wanted to show it off, right?
Some other YouTubers were visiting. Jake Laser, Nigel from Nyler, and Alan Pan. They decided to give them a demonstration.
Must be nice, showing off your giant robot to your internet-famous friends. But something tells me this wasn't the ending they were hoping for.
It's a bittersweet moment for sure. Megahex is walking great, better than ever, right in front of the cameras. And then One of the excavator frames, it just snaps in half.
Oh, man. I can't imagine how devastating that must have been. All that work, and then it just breaks.
It really shows you, even with all the engineering in the world, you can't always push things past their limits. Those excavator frames just couldn't take it.
So, what happened next? Did they give up?
You know, it's amazing they actually tried to fix it. They thought maybe it was just a one-time thing. They repaired the frame and got ready to test again. But as we'll talk about after a quick break, it wasn't that simple. They were starting to see that maybe, just maybe, excavator legs weren't the best choice for a giant walking robot.
They put so much into this thing. Time, money, I bet they were emotionally invested too. And then, that broken excavator frame, what'd they do?
It's a tough spot to be in, you know? Do you keep pushing or do you accept that maybe sometimes it's just not going to work?
They fixed it though, right? What happened when they tried again?
They were hopeful, you know, thought maybe it was just bad luck. But nope, same thing, same leg buckled, different spot this time.
Like the robot was telling them, hey, these legs, not made for walking.
Yeah, pretty much. It became obvious those excavator frames, they just weren't strong enough, especially at that size. They had hit the limit.
That must have been tough to swallow. So close to making it work, and then bam, back to square one.
They had a big decision to make. They could redesign the legs, try to make them stronger, but that's more time, more money, and no guarantee it would even work.
It's about knowing when to call it a day, right? When to be practical.
Exactly. So they thought about it, looked at all the data, crunched the numbers, and they decided to stop. No more Megahex.
I bet that was hard
Yeah.
after all that work. But there's something to be said for knowing when to stop.
Definitely. And in their video, they talk about what they learned, about failing, and how it's not always a bad thing.
It's a good lesson, right? We're so focused on showing success, but failures, that's how we learn. So what did they say? What did they learn from Megahex?
They said, test, test, test. Don't be scared to try new things, but also be realistic. Things have limits. And they said, learn from your mistakes. Keep trying new things.
And they talk about their viewers, right? All the people who watch their videos.
Yeah, they said, without those viewers, this project wouldn't have happened. It was too expensive, too risky. People were excited about it. That's what kept them going.
It's cool, right? Even for something as big as a giant robot, it all comes down to people. Curiosity, wanting to see what's possible, and it takes a whole community to make something like that happen.
What's great about their video is they're honest. They talk about the downsides, the money, the stress. It wasn't all fun and games.
It makes it real, you know? It shows what engineering is really like. And it shows that failing, well, it's not the end of the world.
So here's a thought for you, listener. Imagine you were building Megahex. What would you do different? What would you change?
It's easy to say now, after seeing what happened, right?
Right.
But to really think about it, to make those choices, that's a whole other thing.
So keep that in mind. Maybe, just maybe, you have the next big idea for a giant robot. Until next time, keep exploring, keep asking questions, and keep diving deep.